Hey folks, I am Pharmacist Phil. Real talk. Science terms can sound like a different language. Today I will break them down so you can tell strong evidence from weak claims. This video is for education only and is not personal medical advice. Not all studies are created equal. The way a study is set up affects how much you can trust the results. A clean design means fewer hidden sources of bias. Let us keep it simple and plain. A randomized controlled trial is the strongest way to test a treatment. People are randomly put into groups. One group gets the treatment. Another group gets a placebo or standard care. Random assignment helps make the groups similar at the start, so differences at the end are more likely due to the treatment. For example, you can test if vitamin D3 improves muscle strength by giving half the people vitamin D3 and half a placebo. An observational study watches what happens without telling people what to take. Researchers might compare people who already take vitamin D with people who do not. These studies can show links, but they cannot prove cause and effect. Maybe people with higher vitamin D levels exercise more or eat better. That can confuse the results. A systematic review looks at all the studies on a topic using clear rules to find, select, and rate them. It gives you the big picture and reduces cherry-picking. A meta-analysis goes one step further. It combines data from many studies to get a more precise estimate. When small studies disagree, a meta-analysis can clarify the overall effect. Blinding helps prevent bias. In a blinded study, participants and sometimes researchers do not know who got the treatment and who got the placebo. This keeps expectations from tilting the results. Sample size matters. Bigger studies usually give more reliable answers. As a simple rule, over 100 people is better, and over 1,000 is stronger for common health questions. A control group is the comparison group that does not get the experimental treatment. Comparing the treatment group with the control group helps you see what really changed. Now let us talk about results. Statistical significance means the result is unlikely to be due to chance. You will often see a p-value less than 0.05. But significant does not always mean important. If the effect is tiny or the study is small, it may not matter much in real life. Always ask, how big is the benefit, and does it matter to patients? Funding is worth a quick look. Knowing who paid for the study gives you context. Company funding does not make a study bad, but it is something to keep in mind. All right, here is your quick checklist you can run on any study. Is the study big enough? Did it have a control group and random assignment? Were participants and researchers blinded? Are the results both statistically significant and meaningful in real life? Who funded the study? Do the findings match other high-quality studies like systematic reviews and meta-analyses? Let us wrap it up. Randomized controlled trials and meta-analyses usually give the strongest evidence. Observational studies can suggest links, but they do not prove cause and effect. Systematic reviews and meta-analyses help you see the big picture. Always check sample size, controls, blinding, significance, and funding. With these tools, you can read health headlines with confidence and make better choices. If this helped, show some love and tap like. Subscribe to the channel and turn on the notifications bell so you do not miss new videos. For your next step, watch my video called Vitamin D, Who Benefits Most When Levels Are Low. It is linked on screen and in the description. Drop your questions in the comments. I am Pharmacist Phil. Stay curious, and I will see you in the next video.